All right, where did we miss? Did we go through here? Sarah?
Huh?
Did we go over here? Where did we miss?
From what I heard, it was, yeah, it was, you started the third line for me.
Okay. Well, this is a little bit okay, basically I just repeat it until here, and then we just kind of cancel out p percent 28k here, and then that's this line, and then we subtract p plus 25, p plus 0.25% m, so this becomes 1.75% m equals 2% 28k. So what percentage can removed, and m equals 2 times 28k divided by 1.75 equals 32k. Okay, so the key thing is it cancels out, the complex part is canceled out, so we can actually get a number in the end. Basically, p is all canceled out. P doesn't matter here. So. Okay, I think we spent a lot of time in homework. Let's see what else we are missing here. Did we do well on 6? Let's see, 6 is not too bad, I think. Oh, 6 is also problematic. Okay, what do we have in 6? Am I sharing my screen, by the way?
No, not sharing.
I'm not. Oh. Okay, so number 6. Where's number 6? This is number 6. Probability that the ace of spades lies next to the jack of diamonds in an ordinary 52 cards. Use fraction. Okay, this problem is simple enough, but how do we, what's the thought of doing this? Anyone?
Yeah.
Mhm.
There's only 2 possibilities of where the jack of diamonds and the ace of spades are next to each other. It's where it's on top, and if it's on the bottom.
Go ahead.
So it's only 2 out of a total of 52 cards. So basically 1 out of 26.
52 cards. So you can be either there or there. I think that probably makes sense. It's a little bit hard to argue with that. But suppose you have an ace of spade anywhere. Now, do you always have both top and bottom available? No. And assuming you are always in there, how is this going to? I don't know, the answer is correct, but the way of thinking is a little bit too simple. For example, your card, your ace could be on the bottom, then there's only one chance, and or on the top, very top, right? Okay, so the way to do this problem is, let me stop just a little bit. So we're thinking about 52 cards here. Okay, so the two cards are always together. So let's say we just put them, we can staple them together into one. Okay, then this card can be together with the other 50, right? So there's totally 51. They can do whatever they want, right? That's 51 factorial. Everybody follow? Actually, I see some reflection here. So the reflection is here, and all the way to here. Okay, this is my not good zone. All right, so we kind of staple together these two, and with all other 50 cards, they can do the full arrangement, right? This is the P51, 51, right? That's equal to 51 factorial. So there are so many arrangements to make these two together. Okay, but what will be my denominator, right? We're talking about probability, right? So it's gonna be what? What's the denominator here?
Yeah. 52, 52.
52, yes. So we actually we're actually arranging all 52, but all these means they're together, okay? So that's 52 factorial. However, this has, in general, it has two, staple them together is one case, but switch between the two, they're still one, they're still adjacent, right? So we should really times 2 in here. And that will times 2 in here, okay? So times 2. So if the probability should be 2 times this whole thing divided by 52 factorial. So this equals to 2 times 51 factorial. This is 52 times 51 factorial. Eventually it's canceled out. This becomes 1 over 26. Okay, it's the same answer that Sarah provides, but I'm still I don't know if that's an acceptable solution that Sarah just mentioned. It probably is. Ultimately, they will equal, but the way to think of it, this is the correct way to think of it for now. Okay. All right. What we got in the next one? 6. So we have 6, 7. Even 7 is a little bit problematic, and 8. So 7, 8, 9. We should all do all 3. 7, 8, 9, and okay, 7. 3 successive rows of a die. Maybe I should reshare. Got it. So 7, 8, 9. So we should try to finish these 3. 3 successive rows greater than 3. What is the probability that they are all the same? Okay, this should be very straightforward. So anyone wants to talk this over?
Can I do it?
Who is this?
Ayushi?
Ayushi, okay. Which group are you?
4.
4, okay. Go ahead, Ayushi.
So it could either be 4, 5, or 6. So there's 3 different possibilities. And so it say the first one was a 4, then the probability that the second one is a 4 would be 1/3, and then right times 1/3. So the second and third. So 1/3 times 1/3 is 1/9.
Yes. So if I got you correctly, so there are only 3 possibility, which is 4, 5, 6, right? Because it has to be greater than 3. So the numerator should be 3, and denominator should be, you have 3 possibility for each one. Denominator should be 3 to the third. So the 3 divided by 3 to the third is 1/9. Okay, so that's the correct answer. Everybody followed? I think this should be pretty straightforward, right? We don't have to spend too much time on it. Let's go to the number 8. Okay, this will be interesting one.
I do it.
Okay, who is this?
Landon.
Landon, go ahead. Are you number 3? Group 3?
Group 1.
Group 1. Okay, go ahead, Landon.
So for decreasing order, it'd be 10 factorial over 7 factorial times 3 factorial.
How do you get that? Yeah, can you annotate here a little bit?
Okay. Wait. So for the decreasing order, it'd be 10 factorial over 7 factorial times 3 factorial.
How did you get this part?
Because for decreasing, you can also have 0, but in increasing, it'd be 9 factorial over 6 factorial times 3 factorial, since there's no 0.
Okay. And why do you divide 3 times 7 factorial?
What?
So how do you do the denominator part?
Oh, this part I divide by 7 factorial because, wait, let me think. I'm not sure, but I found out I did 3 factorial because that's how many spots there are. And since it was 10 factorial, I did 7 factorial.
Okay, 7. I mean, 3 would make sense. 3 is to get rid of the repeating ones, right?
Yeah.
And what about 7? I'm not sure.
I use combination to do it.
So what's the combination, your expression?
C 10 3.
Yes, that's correct. What about this is a decreasing, right?
Yeah, and for increasing it'd be C 9 3.
Perfect.
And then the answer in total is 204, I think. If memory's okay.
Yeah, that's exactly right. So I'm just going to elaborate a little bit from what Landon just said. So if you look at all these numbers, they can be anything greater than 100. But if you pick 3 numbers, if you pick any 3 numbers, there will be only 1 chance to have the correct arrangement. Let's say the increasing one. Okay, that's the increasing one. So increasing ones, there will be no chance to have a 0, right? Because the the 100th digit is 1. If it's increasing, there's no chance to have 0. So it's gonna be, you select 3 numbers from 9, so 1 to 9. You select 3 out of them. Once you select, that's done. You're done. There's only 1 possibility to meet increasing. Okay, so basically you just select 3 out of 9, you're done. And similarly, if it's decreasing, then 0 is a possibility. So the same problem, you select any 3 numbers from 10, so that's 0 to 9. Any 3, you select, once you select, job is done. It has only one arrangement to make it always decreasing. Make sense? So question is welcome. This is really good. There might be other ways too. You know, you just, let's say, you know, I can probably share just a little bit on this problem, because not many chance we can think about this way. Let's see where it is. Okay.
Can you explain 8 again?
Yeah, I'll do it right now. So this is which one is this? Number 3, yeah. So we have an answer right in here. Okay, we have 2 ways. Lyndon, do you mind wiping off those annotation? Or maybe I can do it. Yeah, good, thank you. Yeah, so there's one straightforward way, right? So we can start from increasing, right? First digit 1, second digit 2, then third digit can be 3, 4 until 9, so totally 7 possibility. Similarly, we can say second digit is 3, and then totally 6 possibility, and then continue. You got 7 plus 6 plus 1 equals 28. This is all for when first digit is 1. And then similarly, you can just add them together to 6 equals 21 when first digit is 2. Similarly, you got, you know, you just kind of add them together so until you get the final number 84. And for decreasing, the same number will, you know, with opposite digits plus all possible 2 digits plus 0. So this is just going to be 8 plus 36. So this is 36 is the extra for the decreasing. So totally we're talking about 204. Okay, and this is you know, probably the way most people will start, but this is the smart way would be, you know, how do we treat this problem, right? You treat the problem is for all possible 3 digital numbers for increasing case, it just selects 3 numbers from 1 to 9. So once it is selected, right, there is only one arrangement to make them increasing, right? Any 3 numbers, there's only one order to make them to meet the requirement, right? So this means we just select, so how many possibility? We select the 3 out of 9. Okay, everybody got this part? Once you selected 3 numbers, you're done. And for decreasing case, it's just similar but includes 0. So it's C10 3. So totally is C9 3 plus C10 3. And this gives us 84 plus 120. That's 204. So this will be a much faster way to think. But you should also understand the general way to it. Okay. Just give a little bit time for you to digest. If you have question right now, go ahead and ask. Otherwise, let's go back to problem 9. Or is that 8 or 9? Okay, fine. Oh, yeah, problem 9. Okay, this is interesting. Let's read the problem. And let me know if you want to talk this over.
I can try it.
Who is this?
David?
David, who?
Yes.
Which group are you in?
Wait, I haven't checked.
Let me check. So you're in group 1.
Okay.
Okay. Yeah.
Okay, so 3 to the a power can have unit digits 3, 9, 7, and 1, right? And these all have an equal chance of happening. And 7 also can have units digits. 7 has unit digits 7 to the b power can have unit digits 7, 9, 3, or 1, also all with equal probabilities of happening. Therefore, there are 4 times 4 equals 16 possible pairs of unit digits. However, only 3 of those pairs, 1, 7, 7, 1, and 9, 9, will have a unit digit of 8. So therefore, the answer is 3 divided by 16.
Correct. Yeah, that's exactly right. So the unit digit of the combination of them has totally 16 combination, but 3 of them can yield 8, and that's that's the probability of getting them. And the good thing is the possibility for each of the unit digit is equal, right? They are all just one of the 4, and so it makes this problem easier. Okay, thank you, David. I think we can stop here for the homework, and I'd like to just quickly go over a few things which is important. I don't know why my presentation is getting smaller and smaller.
As you press zoom in, so just
maybe
do
this one.
control minus.
Okay.
Control minus. Control minus. Control minus.
Control minus. Okay, thank you. Okay.
Yeah.
All
Too
right.
less. Too much. Too much.
That's okay. Yeah, this is good. I want to quickly go over this one because I want to introduce this general way of handling things. So let me present this, and you can have a chance to read the problem. Okay, I'm gonna assume you finished. So basically, we are doing the rearranged, right? And these letters has repeating elements. So for example, if there's no repeating, it's just 9 factorial, right? But now we have what, 3a 2n, right? So this what I want to just kind of introduce the way to deal with identical letters here. So we think in the opposite way. So without identical letters, it should be P99 or 9 factorial. Now we have, let's assume we have 3 identicals. Then you think backwards. So if we just look at the other letters plus these 3 identicals, and whenever these 3 are doing arrangements within themselves, the whole combination will treat them the same, right? So if you look at this way, then you should be able to figure out that P99 or P99 divided by P33 should be the actual number of arrangement. So it's a little bit tricky here. So let's say a number of arrangement is X, is X for this thing, okay? Now, these 3 elements, and suppose they are doing P33, it doesn't increase at all. But assuming they are different, then you multiply by P33, it will be equals to P99. Okay, so this will be the answer to deal with the identical letters in this case. Similarly, if you have 2 identical elements, it's just going to be divided by P22. So now for this problem, so we want to use P99 divided by P33 divided by P22 is 9 factorial divided by 3 factorial. times 2 factorial. They're both in denominator, and to get this. And I won't leave you some time for you to digest offline, but I want to basically put them in general way. So if there's n elements, then it contains P1 identical element 1, P2 identical element 2, until Pm identical element 3. So in general way, then the total arrangement will be n factorial divided by P1 factorial, P2 factorial until Pm factorial. Okay, so this is how we deal with the repeating element in the permutation problem. All right. So let's just do one problem here. I think we have this one already, and this one is a good one. I'll leave it to the last, and let's do this one. Okay, spider one. Let's have 2 minutes. Okay, anyone has any idea? It's a multiple choice. It should be easier for you. Well, if you have an answer, even you don't know how you get it, but you can narrow down to one of the 5 answers. You can also speak up.
Can I do it?
Who is saying?
Dylan,
Okay, Dylan, go ahead.
I don't know how I don't remember how I got the answer, but I think it is C.
Oh, that's incorrect. Unfortunately.
Okay.
Okay. But yeah, go ahead to see what's your thought?
Is it B?
Boy?
B.
Is it boy or dog you're talking?
Is it boy?
No,
Is it
we only have 3 more answers. Come on.
is it elephant?
Dog. Dog. It's
Not elephant, not apple.
Dog.
I remember I had D as my answer, but then I changed it because I thought something was wrong with it.
Mhm.
No, we don't think you're lying at all.
Wait, but Chloe, I did it.
Is it, so now you know the answer D. Does anyone know why?
This does not look believable. Chloe.
Anyone?
No, I don't
No?
understand this question.
Oh, wait, it's D because there's 16 factorial ways that you can put its shoes on, because that's 1 sock and 1 shoe, and over 2 each time. So it's 16 factorial over 2 to the 8th because it has 8.
Why 2 to the 8?
Because it has 2 choices.
2 choices. Why not 2, but 2 to the 8th?
There's
Wait.
8 legs.
Wait, what did you say?
No, you said 2 choices. Or what? Can you be clear what two choices you're talking about?
For a sock and a shoe.
Sock or shoe? Yes. This is Anish.
Yeah.
Okay, that's correct. Let me see if I can annotate a little bit. So this is pretty straightforward. So we have 8 legs, right? And every leg you can have either shoe or sock. So there's totally 16 elements here, right? 16 elements. That means what do you call it? Because order matters, right? You can say leg 1 shoe, leg 1 sock, leg 2 shoe, leg 2 sock, you know, or you can shoe 1, shoe 2, shoe 1 to shoe 8, sock 1 to sock 8. Okay, so totally 16 elements. Okay, if there's no order requirement, we should be looking at 16 factorial, correct? Everybody follows? 16 elements. They can do full arrangement, right? Okay, nod if you agree. We don't want to lose whatever we learned while learning new stuff, okay? Now, do you remember what we just talked about? We have repeating element. What kind of repeating element do we have? If you think the final answer is n, right? There are so many arrangements. And now we limited the shoe and sock. So it's as if the shoe and sock is identical. So if we now allow the shoe and sock to have random order, that means every leg will have 2 times 2, multiple, I say double the arrangements. Okay, just give you a second. So now we limited the order of shoe and sock for each leg. Okay, now let's say with this limitation, our final arrangement is n. Okay, now if I relax this requirement, if we relax it, there's no such limit. It will be, we got 4 minutes. Okay, that's good. So there will be, each leg will have double the choices, right? And then how many legs? 8, right? And if you multiply this and times this, this will be our full arrangement as if there's no order limit, which is what? Which is what? Sarah, you're avoiding the eye contact. Come on. No limit, right? No limit. How many elements we're talking about?
16.
No limit. What's the full arrangement of 16?
16 factorial.
Yeah, 16 factorial. Okay, so is this so different than the one that we just had? Now, those 8 letters, 9 letters, there's 3 repeating, 3 identical. And we want to try to find how many arrangements in there. And this is like the same thing. But if you're not thinking that's the exactly similarity exists, but let's think about this way. Okay, so whatever the final arrangement, that's n, but if you relax that order limit, then it's going to be 2 for each leg, right? So totally 8 legs, that's 2 to the 8th. You multiply together, that should give us the full 16 element arrangement. Still no? But you can think this way, right? So suppose, let's say, you have an arrangement of the 16 element, okay, with some limitation. Now, each 8 will have a different, how to say, what should I say to make it easier? You have totally n now, but now this n comes from 8 stuff. Okay, now each of them become double, right? They can double it. He can double it. It can double it, double it, double it, double it, double it. So totally, you should be able to have the full arrangement of all these. Okay? So n times 2 to the 8th should be 16 factorial. And that will be our final answer. Okay? Hopefully you can get this. If not, do some head scratching after the meeting. It's a very important one because we're gonna see this problem all the time. We're gonna be kicked out in a few seconds. So,
Hi, this is me, Dylan, again. So you're saying that 16 factorial is equal to 256?
no, that's much more than 256. 16, you're talking about 16 square, right? That's 256, but 16 factorial